All right, guys. Welcome to Unit 8 of AAF. So this is a new unit. We're going to be using some of the stuff that we did in the last unit and some things that you guys have done in general. A lot of what you are going to see this week may be review. You guys might be coming from some different schools with some different backgrounds with geometry, and that's fine. So again, you guys have access to the PowerPoints if you want to print them out or follow along. So for these, we are solving for the indicated side length or angle measure. And I'm not really telling you how to do that. I just want you to use some of your background knowledge. So let's get started with this first one. So we have a rectangle, right? So there's right angles. I know the length of the diagonal. I know this side. That means this side must also be 12. So how can you figure out this side length? Oh, the Pythagorean theorem, right? So x squared plus 12 squared equals 15 squared. X squared equals 100, plus 144 equals 225. When you subtract 144, do you get 169? Oh, no, you don't. Sorry, I just had a moment there. You get 81. And then when you take the square root of that, you get 9. Right? So then we get x is 9, which is also this side length, right? That would also have a length of 9. Oh, sorry. All right. What about this one? So we've got another right triangle. And for this, we're solving for x. We're solving for these two angle measures. Right? So if this is 90 degrees, maybe you remember the triangle sum theorem from geometry. Right? That means that the three angles add to 180 degrees. They sum to 180 degrees. So these two angles, this one and this one, have to equal to 90. They have to sum to 90. And then we're just simplifying this out. So that's 7x plus 6 equals 90. Minus 6, you get 7x equals 84. Therefore, x must be equal to what? 12. Right, so then if we wanted to actually figure out those angles, let's do a new color. Right, so maybe I actually wanted to know this angle measure. I would say it's 2 times 12 plus 1. That's going to be 25 degrees. And I could plug it in here, or I could just think, well, this has to be 90 minus 25. So this is actually going to be 65 degrees. What about this one, right? So you've got this angle. This is x, this is 2x. Well, x plus 2x, and maybe you already know it, right? This one has to be double that one. And they have to add to 90, right? So 3x has to equal to 90. Therefore, x has to be 30. So this angle is 30 degrees. This angle is 60 degrees. Maybe you know something about a 30, 60, 90 right triangle. Maybe you don't. Either way, we're going to be talking about that today. And finally, this last one, again, a right triangle. So we can go ahead and use the Pythagorean theorem. So we've got x squared, right? This is the hypotenuse. X squared plus 6 squared equals 10 squared. X squared plus 36 is going to equal to 100. Therefore, x squared must equal to, is that 64? So x is going to be equal to 8. And maybe you remember some like Pythagorean triples, like the 3, 4, 5 right triangle. This is just double that, right? Like it's a dilation. Maybe you remember this, the 9, 12, 15. Right, so there's some Pythagorean triples that maybe you remember, maybe you don't. It's okay, either way. Awesome. So what we're going to be looking at on this objective is using some of this knowledge that we have from geometry to define the 6 trigonometric functions. You may have learned them in geometry. You may have learned at least 3. Maybe you know 3. Maybe you know all of them. Maybe you don't remember any of them. That's okay. Within a right triangle, so our focus is going to be on right triangles. So we're going to be using things like the Pythagorean theorem to help us out here because we're still working with right triangles, specifically special right triangles. So the special right triangles that we're going to be looking at are 30, 60, 90 and 45, 45, 90. Those are special right triangles. All right, this is an isosceles triangle. And again, like based off of where you went to school and what they did with geometry, or maybe even earlier, you might know this stuff, but it's also possible that you've never seen special right triangles at all, and that's okay as well. I'm going to be going through it in this lesson. So let's start with the parts of a triangle. Given a right triangle, ABC, the side touching angle A is adjacent to angle A. So in this image, the way I have it labeled, I'm assuming angle A is my reference angle. I'm going to put a theta there, right? So this is my reference angle. Opposite and adjacent are going to depend on your reference angle. The hypotenuse is not. Right? If you recall for the hypotenuse, it's always going to be opposite of the 90-degree angle. So no matter where your reference is, whether it's at A or it's at C, that's not going to change, but the opposite and adjacent will. So the side touching angle A is adjacent to angle A. Ooh. Okay, there we go. The side across from angle A is said to be the opposite of angle A, and the longest side across from the right angle is called the hypotenuse. So the trig functions in any right triangle, the trigonometric ratios are as follows: tangent, sine, and cosine. Tangent is opposite over adjacent. Sine is opposite over hypotenuse, right? So it's ratios, you're comparing the two side lengths. Cosine is adjacent over hypotenuse. So these will be the same in that I made mention to like the 3, 4, 5 right triangle and the other one being a dilation, right? 3, 4, 5 is 6, 8, 10. Like no matter what, the ratios are going to stay constant. So they are the same no matter what right triangle we have. Sine is always going to be opposite of hypotenuse. So maybe you remember this acronym for remembering. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Right? So SOHCAHTOA is a mnemonic device to help you remember the trig ratios because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We also have the reciprocal trig functions, right? So these are cosecant. These might not be familiar to you. I know I did not teach these and have never taught these in geometry, so it's possible that you've never seen these before. So this is cosecant. Cosecant is the reciprocal, so this is going to be 1 over sine, right? Because sine is opposite of hypotenuse. Oh, sorry. I went too fast. Secant, so this is 1 over cosine, because cosine is adjacent over hypotenuse, so it's the reciprocal of that. And then, cotangent is 1 over tangent. Oh, is cotangent, sorry. I wrote that the wrong way. Right, so that's where I'm getting 6. Okay. Let's look at some examples of how this can be used. So example 1, given the triangle below, determine the following. So the sine of L, the cosine of L, the tangent of L. So that means L is my reference angle. So let's label the sides in reference to this. Well, the hypotenuse never changes. Opposite, oh, it's that 8. Adjacent, oh, right here. This is my right angle. Should have had that drawn in, sorry. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Therefore, the sine of L, well, I now have it labeled, is going to be 8 over 10 or 4/5. The cosine is going to be adjacent over hypotenuse, so 6 over 10 or 3/5. And finally, the tangent is going to be 8 over 6, which is 4/3. Maybe you even remember going a step further and that tangent is just the sine over the cosine. Maybe you remember that, right? Because if I just did, well, 4/5 divided by 3/5, what can you do instead of dividing by a fraction? Multiply by, oh, the reciprocal. Those will cancel, and oh, look at that, you'll get 4/3. Another good thing to know, and sorry, I'm just going to spiral now, is that the sine is always going to be less than 1. Right? So like when we're doing these, it's actually going to be somewhere between 0 and 1. Same thing with cosine. Right? But it's not for when we're talking about the triangle. For tangent, that can be greater than 1. Right? We can get a number that's larger than 1. Here we even got a number that was larger than 1. But for sine and cosine, you're not going to. Because if you're dividing it by the longest side, the opposite or adjacent have to be smaller. So you're always going to get a number that's smaller than 1. Okay, let's look at another one. Whoa, what is this? Given the triangle below, if the sine of L is 1/3, now I'm telling you the sine, but I have nothing labeled here. But I do know that the sine is opposite over hypotenuse, right? I remember. SOHCAHTOA. Right? So if here's my reference angle, L, opposite, oh, this is 1. Over hypotenuse, oh, this is the hypotenuse, right? So this is opposite, this is hypotenuse. How can you find the adjacent? I feel like we did this on the warm-up, right? Because we're going to need it in order to figure these out. We need side KL. So 1 squared plus KL squared equals 3 squared. 1 plus KL squared equals 9. KL squared equals 8. Therefore, KL is the square root of 8. I'm going to choose to simplify that, right? This is 4 times 2. So this is going to be equal to 2 root 2. So this side is 2 root 2. So if we want to know the cosine, well, cosine is adjacent over hypotenuse. So 2 root 2 over 3. What about the tangent of L? Opposite over adjacent. 1 over 2 root 2. Right? Sometimes you might want to rationalize that if you're not someone that fully feels confident doing that, I still encourage you to try it, as that would be a good skill to have, especially if you're doing something that's multiple choice, right? So I don't want, when I'm saying rationalize, I don't want a radical in the denominator. The only thing you can multiply this by without changing it is 1. So if I multiply it by root 2 over root 2, that's not changing it because that's multiplying it by 1. What this does for us is I would now have a root 2 in the numerator over 2 root 4. Wait, root 4, we know that. That's just 2. So it's the square root of 2 divided by 2 times 2, which would be root 2 over 4. So that would be the tangent. So this is, I'm going to say, try to rationalize. It's a good skill to have. All right. Ooh, what about this? Oh, this is interesting. Given the triangle below, determine the following: the sine, the cosine, and the tangent. Let's see. Oh, we're just going to have to do some ratios, I guess. So it looks like L is our reference. So this is opposite, this is the hypotenuse, and this is the adjacent. So sine is opposite over hypotenuse, so it's just going to be y over 1, which is just going to be y. Cosine, adjacent over hypotenuse, x over 1, which is just going to be x. Tangent is opposite over adjacent, so it's going to be y over x. Whoa, isn't that cool? That's sine over cosine. Like sine over cosine. What is the reciprocal? Because I didn't ask these. What is the reciprocal function of sine? Cosecant. What is the cosecant of L? Well, if the sine is y, the cosecant is going to be 1 over y. What about the secant of L? That's the reciprocal of cosine. The secant of L is going to be 1 over x. What about the reciprocal, the cotangent of L? Well, that's going to be the reciprocal of this, x over y. Right? Instead of it being sine over cosine, I'm going to have cosine over sine. Is really what's happening. Right? What if you changed your perspective and I said, hey, what is the sine of j? Right? And this became your focus. Well, then your opposite and adjacent would switch. So like this would be x. Right? The cosine of L and the sine of j are the same. What about the cosine of j? The cosine of j would be y. Oh, the cosine of j and the sine of L are the same. The tangent of j would be x over y, which is actually just, oh, that's interesting, the cotangent of L. Interesting. So we're going to use some of this information and work with this and tie this in with some information about special right triangles, which again may or may not be a review to you guys. So the first one we're going to look at is a 45, 45, 90 right triangle. So I have a square here. I'm going to draw the diagonal in and call it D. So this is now a 45-degree angle. The diagonals of my square bisect the angles. That's a 45-degree angle. So right now, if I wanted to solve for D, I could set this up. D squared equals x squared plus x squared, right? This is x. This is x. So I'm dealing with this like right triangle right in here. Maybe I can outline it, right? So this right triangle where I'm doing x squared plus x squared equals d squared. So if we simplify this a little bit, we're going to have d squared equals 2x squared. I can take the square root of both sides, and I'm going to be left with d equals x root 2. So the length of d is x root 2. So what does that say about a 45, 45, 90 right triangle? Well, the three sides are going to be x, x, and x root 2. That will always be true, right? So let's say this had been 7. This would be 7, and this would be 7 root 2. Right? Like we could try and work that out. 7 squared plus 7 squared equals d squared. 49 and 49 is 100. What is that? Oh, no, it's not. It's 98. Sorry. Equals d squared. And then you'd go to take the square root. And when you go to simplify this, well, that's 49 times 2, right? That's how I arrived at that. Oh, that's just 7 root 2. Right? So this is a special right triangle because this is a pattern that will always exist, right? We can even go the other way. Like what if you didn't know what x was, but I told you that d was 10 root 2. Well, then what are these two side lines? Oh, well, it's 10 and 10, right? And again, you could have set that up and said, well, x squared plus x squared equals 10 root 2 squared. And then this is going to be 2x squared, and this is going to be 400. You'd have to do x squared equals 200 and square root, and then we'd say x is going to equal to, I messed that up somewhere along the way. This is a 200. That's a 100. X is 10, right? But knowing this pattern, knowing this, we're going to simplify things for ourselves. We're going to be able to work quicker when we begin to apply this. So in a 45, 45, 90 triangle, the length of the hypotenuse is root 2 times the length of a leg, and the legs are congruent to each other. So if we want to find the missing side for these. So this first one, well, 6 root 2, right? If I say this is x and this is x, so x root 2 would be equal to 6 root 2. Divide by root 2. We're going to get that that side length is just equal to 6. So this is 6 and this is 6. What about this one over here, right? So 8 is going to be equal to a root 2, right? The hypotenuse is equal to root 2 times the length of a leg. So I'm going to divide by root 2 and divide by root 2. And this is where it would be fabulous if we can try to rationalize. So I'm going to multiply by root 2 over root 2. Because this is a. I have it now, but I just want to rationalize it. So I get 8 root 2 divided by root 2 times root 2 is root 4, which is just 2. So it's 4 root 2. Right? So a equals 4 root 2. So this side would be 4 root 2. And this side would be 4 root 2. And if you want to check if that works, we can go ahead and say, well, what if we had done 4 root 2 times root 2? That would have given us 4 times these two. Root 2 times root 2 is just going to be 2. Oh, that's 8, right? You can check your work. Oh, look, I got it right. Let's do a few more practice. I would say this would be a great time to pause the video and try these on your own. So here, I'm going to solve for all missing sides. We know these are isosceles. This is 45 and this is 45. This is 3. Therefore, this is going to be 3 root 2. Let's say the side is going to be, the side times root 2 is going to be equal to 8. I'm going to divide both sides by the side. So I'm going to have the side is equal to 8 root 2 over 2, which is going to be 4 root 2. Oh, didn't we do that one? What about this? The diagonal is 14. This isn't well indicated, but if the sides opposite are this is a square. It has to be. I should have marked that clearer, sorry. So the diagonal is 14. So when we do the side times root 2 is going to be equal to 14. Divide by root 2. So the side is going to be 14 root 2 over 2 when I rationalize. Right, because I'm going to multiply by root 2 over root 2. And this is just equal to 2. So that's 7 root 2. So this side is 7 root 2. This side is 7 root 2. This side is 7 root 2. And this side is 7 root 2. This final one is 45, 45, 90 as well. So the side times root 2 is equal to 21. Divide by root 2. Divide by root 2. The side is going to be 21 root 2 over 2. So both of these sides will be 21 root 2 over 2. 21 root 2 over 2. So notice for this one, I was giving you a leg. And for these other 3, I was giving you the hypotenuse. So think about that equation and what part you have and what you're actually working towards. Okay. So just to tie this back in with what we had talked about towards the beginning of this lesson. So I have this 45, 45, 90 right triangle, right? So I can solve for these 2 missing sides. I can say, well, I know that I got 5 root 2, so I got that by doing the leg, the side, times root 2 is 10, and then I divided by root 2, right? And that's where I got these 2 side lengths. So what if I asked you these questions? The sine of 45 degrees, right? So if this is a 45-degree angle, and it really doesn't matter which one's my reference angle, oh look, this is opposite, and this is adjacent, and this is the hypotenuse. Well, let's take it back to SOHCAHTOA. right? So the sine of 45 degrees is going to be 5 root 2 over 10, right? So that's just going to give me root 2 over 2. What about the cosine of 45 degrees? The cosine of 45 degrees is going to be adjacent 5 root 2 over 10 equals root 2 over 2. What about the tangent of 45 degrees? 5 root 2 over 5 root 2. Opposite over adjacent. Oh, that's just 1. Right? And then these are just the reciprocal functions, right? So this is the reciprocal of sine. So it's going to be 2 over root 2, which let's rationalize that. Root 2 over root 2. So I'm going to get 2 root 2 over 2, which is just going to be root 2. What about the secant? The secant is just the reciprocal function of cosine. So that's going to be 2 over root 2 times root 2 over root 2. I feel like I did this math, didn't I? That's just root 2. And then the cotangent is going to be the reciprocal of tangent, right? So instead of it being opposite over adjacent, it's going to be adjacent over opposite, which is still going to be 5 root 2 over 5 root 2, which is still going to be 1. So this is now what I want you to do. And I don't have it pulled up on my screen, but if you have your graphing calculator, I want you to pull out your graphing calculator. And I want you to hit where it says mode. And when you see mode, it says your calculator is going to default to radians. It's the third one down. It says normal, float, and then radian. I want you to make sure that you have degree highlighted, right? We're working in degrees. Hit it and then go back to your home screen. And I want you to plug in the sine of 45 and hit enter. When you do that in your calculator, you get 0.7071, blah, 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 blah. It keeps going, right? Now I want you to put in root 2 divided by 2. Root 2 divided by 2. And keep in mind, the only thing you're taking the square root of is that 2. Oh my gosh, you get 0.7071, blah, 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 blah. Wow. Let's do it for cosine. What do you get for cosine of 45 degrees? The cosine of 45 degrees, also 0.7071, blah, 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 which was also root 2 over 2. Let's do one more. What about the tangent of 45 degrees? Oh, look at that. You got 1. Right? So what you're actually doing here is you're using this triangle to figure out what is the actual sine of 45 degrees, right? Like these are not made up. So we're using this information about special right triangles to link it with trig. And these are values, like these values that you're seeing with 45 degrees are ones that we're going to work with a lot over the next few weeks, and you will work with it again in pre-calculus and in the future as well. So you will see these a lot. Fantastic. Let's take a look now at a 30, 60, 90 triangle. So right here on the screen, I have an equilateral triangle, right? So that means all 3 sides and all 3 angles are equal. What's the measure of each angle? 60 degrees, right? 180 divided by 3. So I'm going to drop the altitude. I'm going to go from the vertex, one of the vertices, perpendicularly to the base. So this is 60 degrees. This is 60 degrees, but this is 30, right? I'm like cutting it in half. So this length, I'm going to call that side of the triangle 2x. And that's 2x. So that means that these two on the bottom are x and x, right? Like you're splitting it up. That length would also have to be 2x. So if we want to figure out a, we want to figure out that height, we're going to do the Pythagorean theorem again, right? Like we're dealing with this right triangle. This right here, this right triangle. Is there a highlighter? Here, this one. Whoa! That's my highlighter for the day. We're going to work with that right triangle. So a squared equals 2x squared minus x squared, right? So this right here was the hypotenuse, and this was one of the legs. So we did the hypotenuse squared minus one of the legs squared is going to give you a squared. So if we go to simplify this, let's distribute that squared. You're going to get a squared equals 4x squared minus x squared. So a squared is going to equal 3x squared. And then we're going to go ahead and we're going to take the square root of both sides, just like we did before. So we're going to get a is equal to x root 3. So what did we just learn about 30, 60, 90 triangles? Well, the side lengths, here's your 30, 60, 90 triangle, are x, which is your shortest side, right? That's across from the 90-degree angle. The hypotenuse is going to be 2 times the shortest side. That's your hypotenuse. That's your shortest. And this is your longer leg. This will always be true, right? If I told you that this was 10, you would be able to tell me that this was 5 and this was 5 root 3. Like, undoubtedly, like, that's what it is, right? If I had told you that this was 7, that would mean that this is 14 and this is 7 root 3. So it's all stemming from that shortest side, the side across from the 30-degree angle. So let's look at a few examples, right? So in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter side, and the length of the longer leg is root 3 times the length of the shorter leg. So if we want to find the missing sides, so that's 60, that's 30, this is 5. Well, do I know the shortest side? I believe I do, right? So this is the shortest side. So this is going to be 2 times the shortest side. I'm going to say this is your shortest side. I'm going to call it S. And this is going to be your longer leg. So this is going to be the shortest side times root 3, right? So 2S is going to equal 2 times 5. So this is 10. Oh, this is 10. I feel like I accidentally gave this example. And then your other one, S root 3, is going to be 5 root 3. So this side is going to be 5 root 3. Right? 10, 5 root 3. What about this one over here? Whoops, I accidentally wrote over it. Right? So this is 30. So this is like your shortest side. So right now I know that S is 4 root 3 over 3. So let's say I want to find the hypotenuse now, because I know that the hypotenuse is 2S. So if I do 2, maybe I shouldn't do that over there, 2 times 4 root 3 over 3, I'm going to get 8 root 3 over 3. So the hypotenuse has a length of 8 root 3 over 3. The longer leg, the side across from the 60-degree angle, is going to be S root 3. So I'm going to have to do 4 root 3 over 3 times root 3. Oof, that's interesting. So 4 times, well, what is root 3 times root 3? Well, that's just 3. Right? If you think about it, root 3 times root 3 is root 9, which is just 3, over 3. Oh, these 3's cancel. And I just get 4. Oh, this side is just 4. Right? So it's not always that you necessarily have like the nice number on the shortest side, right? You just got to look at what you're working with. So let's see, did I get these right? 8 root 3 over 3 and 4. Go me. So if you have not already tried some of these on your own, I encourage you to pause the video at this point and try these 4 problems on your own. You actually don't have enough for this one right now, but I'm staring at it. That's okay. So for this one, yeah, oops, whatever. This is my longer, right? So this is, I'll call this my shorter side. This is 2 times my shorter side, and this is my shorter side, root 3. So in order to get my shorter side, I'm going to divide by root 3. So if you've got 6 over root 3 times root 3 over root 3, you're going to get 6 root 3 over 3, which is 2 root 3. So my shorter side is 2 root 3. That's this side length. Well, here, now I have s, I'm going to do 2 times s. So 2 times 2 root 3. This will be 4 root 3. Fabulous. What about over here? Well, here's my shortest side. Here's my hypotenuse, so 2s. And here's my longer leg, s root 2. So if this is 2s, divide by 2, you get that s is 4. Multiply s by root 2, and you get 4 root 2. What about over here? Don't like that. So your hypotenuse is 4 root 2, right? So this is 2s. This is s, and this is s root 2. So here, I can divide by 2, and I'm going to get that my shortest side is 2 root 2. So to get my longer leg, I'm going to do 2 root 2 times root 2. Well, that's 2 root 4, which is 2 times 2, which maybe you just went directly to that, which is just 4. So this side is 4. Let's see, what do I want to do for this one? It says find the altitude of the triangle, so we want to figure out this height. Let's say that this is, I don't know, what do you want it to be? 3? So this is going to be 1.5. This is going to be 1.5. And this would be 1.5 root 3, right? Or you would have, why can't I think of it? 3 root 3 over 2, because it's 3 halves. That could have been anything, right? I took this and I divided it in half and then multiplied it by root 3. Great. So now you've done it. You've learned 45, 45, 90, and 30, 60, 90, which are going to be great as we move forward in this unit. So let's check this out a little bit closer. So for this one right here, you have a hypotenuse of 32, and it's 30, 60, 90. So what is x going to be? Half of it, 16. What's y going to be? Oh, 16 root 2. I'm sorry, root 3. Wow. Right? So what if I asked you to find these values again? And we did it of 30, and then we're also going to look at 60. So the sine of 30 is going to be, this is going to be the opposite, this is the adjacent, this is the hypotenuse. So for these three, that 30-degree angle is our point of view. So opposite 16 over 32, the sine of 30, we're getting 1/2. What about the cosine of 30? 16 root 3, adjacent over hypotenuse, 16 root 3 over 32. That's going to be root 3 over 2. What about the tangent of 30? Opposite over adjacent. Well, okay, so that's going to be 1 over root 3. Let's rationalize that. You're going to get root 3 over root 3. I'm sorry, root 3 over 3. What about the sine of 60? Whoa, we got to change our perspective here. Right? So this is 60, right? It's a 30, 60, 90. So now this becomes opposite and this becomes adjacent. So for these three, we're looking at something different. Well, what's the sine of 60? Opposite over hypotenuse, 16 root 3 over 32. So that's root 3 over 2. Whoa. That's the same as the cosine of 30. Those were complementary angles. Do you remember that? What about the cosine of 60? It's going to be adjacent over hypotenuse, so 16 over 32, which is 1/2. Whoa, who would have thought? That's the same as the first one we did, the sine of 30. What about the tangent of 60? Opposite over adjacent, 16 root 3 over 16 is just going to give us root 3. So you probably guessed it. We're going to go back in our calculators. I'm going to tell you what I want you to do. I want you to plug in, and you should still be in degree mode, sine of 30 degrees, and I want you to tell me what it is. I guess maybe I can't hear you guys, but I got 0.5. Whoa! We said it was 1/2. Let's look at another one. What about the cosine of 30 degrees in your calculator? I got 0.866. Well, what if we did √3/2? Because that's not as nice a number, right? √3, whoa, divided by 2, I got, oh my gosh, 0.866 again. They're the same. Wow. What about the tangent? Oh, you know what? What if we did the sine of 60? What if you did the sine of 60? Oh my gosh, you also get 0.86, blah, 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 blah. Right? Which we also got √3/2. Amazing. What about the cosine of 60? Oh my gosh, I got 0.5 because it was 1/2. So what these special right triangles are doing for us, like these are ones that you're going to commonly be exposed to, like 30, 60, 45, like we're going to be working with them a ton. And that's why special right triangles are so important to us. And we don't want to necessarily need to sit there and solve them out with the Pythagorean theorem. And while that's a great skill to have, and I want you to know how to do that, we really want to see and remember these. Like we want our fluency with it to be quicker. So think about how you can use the special right triangles to help at this point and speed it up a little bit. So we're going to finish off with a short exit check that if you have not paused the video at all, please do so. And then play it back and listen and see if you got it correct. I think that's a great way to check your own understanding. So use triangle ABC below to answer the following question. So the tangent of A, tangent, let's see, I remember, SOHCAHTOA, right? So the tangent is opposite over adjacent. This is my reference angle, opposite, 2 and 3. So I need to figure out that third side. 2 squared plus 3 squared equals AB squared. 4 plus 9 equals AB squared. So 13 is AB squared. Therefore, AB is √3. The √13, wow, sorry. So this is the square root of 13. Therefore, the sine of A is 2 over √13. Or I can rationalize that, and it's going to be 2 √13 over 13. The cosine of A, adjacent over hypotenuse, is going to be 3 over √13, which I could rationalize, and it would be 3 √13 over 13. Cosecant of B, so that's 1 over sine. So let's think about, well, what is the sine of B? The sine of B, so that changes our perspective, is 3 over √13. I'm actually not going to rationalize that because I'm going to have to do the reciprocal, right? So I'm going to go up here. It's just going to be √13 over 3. Cotangent, well, that's going to be 1 over the tangent. So let's think about the tangent of B. Opposite over adjacent, so 3 over 2. And then we're going to flip it around, and we're going to get 2/3. So based off of what we did with special right triangles, is this a 30, 60, 90 right triangle, or is this a 45, 45, 90 right triangle? Right, and I really want you to think about like the stuff with sine, cosine, and tangent. Like we just talked about on that last page that the sine of 60 degrees was 1/2, right? That was what we came up with. We said that the sine of 60 degrees, no, it's not, the sine of 30 degrees, sorry, and that the cosine of I'm a mess. It was the sine of 60. Right? The sine of 60 is 1/2. No, it's not. The sine of 30. I was right the second time. I'm all over the place. I'm forgetting where my angles are. The sine of 30 was 1/2. Right? Well, was the sine of the angle 1/2? Is the sine of either angle 1/2? No. Not true. So no. right? It's not 30, 60, 90. Is this 45, 45, 90? It's really easy for us to say, like, we'll just know it's not isosceles. We know it's not. But we also talked about how, I don't know, the tangent of 45 degrees, wasn't that equal to 1? Like, didn't we figure out that was 1 because it was opposite over adjacent and those two sides were the same? Well, the tangent of A and the tangent of B, neither one of those are 1. And therefore, like, no, this is not true. It's not going to be 45, 45, 90. So think about how this all kind of ties in and connects. So what we just did in this lesson was we used and reviewed a lot of your skills from geometry and what you already maybe know about triangles. You probably knew a little bit about trigonometry, maybe not everything, but to define the 6 trig functions, right? Not just 3, all 6 of them now, even the reciprocal functions within a right triangle. And we specifically focused on some right triangles so that we could look at those 45-degree angles, those 30-degree angles, and those 60-degree angles to find those trig functions for those. So if you feel like you need to go back and rewatch anything, go for it. Otherwise, I encourage you to use all of the extra resources as you practice the skills from this video. Thanks.